Good morning, all. Myself, Dr. Jayagopal Gupta, Assistant Professor, Department of Mechanical Engineering, Government Women Engineering College, Ajmer. Today, in refrigeration and air conditioning, we will learn about nomenclature of refrigerant. So, first of all, we will understand what is refrigerant. Refrigerant is a fluid or working medium used for heat transfer in refrigerating system that absorbs heat in evaporator during evaporation from the region of low temperature and pressure and releases heat in condenser during condensation at a region of high temperature and pressure. So what is the processor of nomenclature of refrigerants? We can understand by this. American Society of Refrigerating Engineers has developed certain conventions for use in naming different types of refrigerant. From the number, we can get some useful information about type of refrigerant, its chemical composition, molecular weight, etc. All the refrigerant are designated by R followed by some number R11, R12, R12, R15, etc. Fully saturated halogenated compounds. We will understand first this. These refrigerants are derivatives of CnH2n plus 2, such as methane, ethane. These refrigerants are designated by RXYZ, where number of carbon atoms indicates by X plus 1, indicated by X plus 1. Number of hydrogen atoms are indicated by Y minus 1, and Z indicates number of fluorine atoms. Valence indicates the number of chlorine atoms in that. Only two digits are there with R, then we consider the value of X is 0. Just like if it is R1, 2, so R, X, Y, Z, so this will be 0, 1, 2. X will be considered as 0. So this we will understand with the help of example. So we will take example of R22. We can write this as R, X, Y, Z, where R 0 to 2. So number of carbon atom will be equal to X plus 1. X is equal to 0 here. So number of carbon atom will be 0 plus 1 equal to 1. Y. Number of hydrogen atom will be equal to Y minus 1. Y is equal to 2 here. So number of hydrogen atom will be 2 minus 1 is equal to 1. Z denotes number of fluorine atom. So number of fluorine atom will be equal to 2. The balance will be equal to number of chlorine atom. What is that? That is 4 minus number of hydrogen plus fluorine atom. Number of hydrogen atoms are 1 here. Number of fluorine atoms are 2 here. So number of chlorine atom will be equal to 4 minus 1 minus 2 will be equal to 1. So chemical formula for R22 we can say that is equal to CHClF2 difluoromonochloromethane. Fluorine atoms are 2, chlorine atoms 1, and remaining are hydrogen atom is 1 and carbon 1. In this procedure, we can find out chemical formula for R12 is CCl2F2. R134A is C2H2F4, which is derivative of ethane. Here we can see that letter A has been followed by 134. This A stands for isomer, molecules having same chemical formula composition but different atomic arrangement are considered as different designation, just like R134 and R134A. These are having same atomic arrangement, same chemical formula composition, but different atomic arrangement. So that's why we designated these kind of refrigerant by differentiation in their name. For inorganic refrigerants, these refrigerants are designated by number 7 followed by the molecular weight of the refrigerant. Just for example, like ammonia molecular weight of ammonia will be equal to 14 plus 3 will be equal to 17. So designation for ammonia will be equal to R717. For carbon dioxide, CO2 will be equal to 12 plus twice of 16 will be equal to 14 or 44. This can be written as R744. In same manner, for water, we can find out molecular weight of water is twice plus 16 equal to 18. So designation is R712. For mixtures, which is the mixture of two or more refrigerants, that can be considered as azeotropic or zeotropic mixture. What is azeotropic mixtures? Azeotropic mixtures contains two or more refrigerant at a certain pressure. An azeotropic mixture evaporates and condenses at a constant temperature. There is no variation in temperature while evaporation and condensation of the mixture. Because of this, azeotropic mixture behave like pure refrigerants in all practical aspects. They are considered as pure refrigerant of their constituents. So azeotropic mixtures are designated by 500 series. Just like R500 is a mixture of R12 and R152A. 502 is the mixture of R22 and R115. Here we know chemical formula for R12, R152 as we have understood earlier. So all azeotropic mixture which behave like for pure refrigerants are designated by 500 series. Zeotropic mixtures have gliding evaporation, means evaporation and condensation temperature changes. There is change during the evaporation and condensation. When evaporating, most volatile component will boil off first and the least volatile component will boil off last. The opposite happens when gas condenses into liquid. For a given pressure, the temperature will change in liquid vapor mixture region. However, it was constant for azeotropic mixtures. This results in a gliding evaporation and condensing temperature along the heat transfer surface. In practice, saturation temperature at the inlet of evaporator will be lower than at the outlet. In condenser, the saturation temperature at inlet will be higher than at the outlet. So that's why we are saying results in a gliding evaporation and condensing temperature along the heat transfer surface. Geotropic refrigerants are designated by 400 series. Just like it is a mixture of 404A, mixture of R125 and R143 and 134A. R407A will be mixture of R32, R125, R134A. We will we already know chemical formula for R32, R125, R134A as we have understood in previous slides. So, zeotropic refrigerant are designated by 400 series. So, comparison between different refrigerants, synthetic refrigerants that were commonly used for refrigeration, cold storage, and air conditioning applications are R11, R12, R22, R502. These are synthetic refrigerants. However, these refrigerants have to be phased out due to ozone depletion potential. They are depleting ozone layer. So, synthetic replacement for the older refrigerants are R134 and blends of hydrofluorocarbons. Generally, synthetic refrigerants are non-toxic, non-flammable, and are compatible with various materials of construction. However, compared to natural refrigerant, these synthetic refrigerants offer lower performance and they also have higher global warming potential. So normally COP values are much lower than the natural refrigerants for synthetic refrigerants. As a result, all synthetic refrigerants face an uncertain future. Oldest and most common used for natural refrigerant is ammonia. Ammonia has excellent thermodynamic, thermophysical, and properties, environmental properties. It is inexpensive, it is easily available. However, it is toxic and it is not compatible with some of the common material of construction such as copper and brass. Other natural refrigerants that are being suggested are hydrocarbons and CO2. Hydrocarbons CO2 are used in olden days, but later they were phased out because of some perceived problems such as flammability, high critical, low critical temperatures, etc. In spite of some practical problem, these refrigerants are being considered as they are environmentally safe, inexpensive, and offers good performance. Thank you. This is all about related to refrigerant nomenclature.